Algebraic expressions may contain one or more terms added or subtracted. So a term can be a constant. This can also be an expression. We might have a variable in our expression, and the term would be the variable. We can have a variable plus a constant. In this case, we have two terms. We have the x and the 3. We can have a coefficient with a variable added to another coefficient with a variable. And these terms would be 2x and 3y. Now these two represent addition. We can also have one with subtraction, like x minus y. Again, our terms are x and y. Lastly, we can have 4x squared plus 6x minus 2. Our terms are 4x squared, 6x, and 2. Now let's talk about like terms. Like terms can be, we can combine like terms or terms that are similar. Now, if they're constants, like 5, and another number, say 3, we can combine those and make a total of 8. So let me give you an example. X plus 5 plus 3. These terms are constants and we can combine them. We now have x plus 8. And that would be our simplified expression. So we can combine constants. We can also combine variables that have the same exponent. So for instance, x plus x plus y, we can simplify these two x variables. Notice they are both x's and they have the same exponent. In this case, there are no exponents shown. We can assume that those are 1s. So we now have 2x plus y. Remember that when an exponent, or a variable, does not have a number in front of it, you can assume that's a 1. So 1x plus 1x is 2x. Let's look at some other examples. Here we have an expression that has 3 terms, 5x, 3x, and 2x. Because all of these products have the variable x, all raised to the same power, we can combine the coefficients. So if we add 5, 3, and 2, we get 10x. That's because 5x means we have 5 x's we have 3 x's and we have 2 x's. When we add them all up, we have 5, 6, 7, 8, 9, 10, giving us 10 x's altogether. Now sometimes the variable is not x. You might have y's. So 2y minus y. Remember, this is 1y. So if I have 2, I'm going to take away 1. I'm left with 1y, or just y. We can also have terms that have variables with exponents. So 7x squared plus 3x squared. Again, because the variables are the same and they're raised to the same power, then we can combine the coefficients, giving us 10x squared. What if we have 4x squared plus 5x plus 3y squared plus 2y? Notice that we have different variables and different exponents with those variables. We have an x squared. We have just an x to the first power. We have a y squared, and we have a y. In this expression, we can no longer simplify it, because notice, even though we have 2 terms that have an x in it, the exponents are not the same. So we can't combine these. That's the same situation here. We have 2 y's, but one is squared and one is not. So this expression is simplified. Let's look at a few more examples. Here we have 9x plus 7y minus 3x minus 4y. I like to either use colored highlighters or make a shape or an underline to identify the terms that are alike. I'm going to circle the terms that have x's as variables. And I have 2. I have this one and this one. So I have a 9x. And notice I'm going to include that minus symbol in front of that x variable or that term. This is now read as negative 3x. Then I'm going to underline my y variable or my y term, and I'm going to include that minus 4y. This is now read as negative 4y. When I rewrite it, I want to change the order. I'm going to combine my x or my x terms. 9x minus 3x excuse me, plus 7y minus 4y. Now I can combine these to simplify. 9 minus 3 is 6x. 7y minus 4y is going to give me 3y. This is a simplified expression. Let's do one more. Here we have 8x squared plus 3x plus 9x squared plus 5x. Again, I have two types of terms. I have x squareds and I have x to the first power. I'm going to rewrite to combine my like terms. This part here can be combined to 17x squared. This becomes 8x. So 17x squared plus 8x is now simplified.